Okay, this video is going over the study guide. I have not included the top part of the study guide because those are all just vocabulary terms. I think most people did okay with that. So if you have any specific questions on any of those words, feel free to shoot me an email. But here we have this table with our three forms of quadratics on there. We're asked to name them, say why they're used, and give another example. So our name here would be the general form. Here we have the vertex form, and here we have factored form. Alright, general. Why general is used, or what it gives us. C is our y-intercept. And a lot of times real life situations are given to us in general form, like when we throw the ball up in the air, that would give us where our ball started would be C. And a lot of times that's what form those kind of problems come in. An example would be y equals 2x squared plus 6x plus 9, or anything like that. Vertex form. Vertex form, we have A, which is our scale factor, which we also have A. We have A in actually all three of the forms. So we have our scale factor. We also are given the vertex in vertex form. H, comma, K is our vertex. So a lot of times that's the main benefit of vertex form. An example would be y equals x minus 3 squared plus 32, where our vertex then would be at 3, 32. Okay, and then finally factored form. Factored form, the biggest benefit here gives us the roots or the zeros. And of course those are what can be plugged in here to make this set 0, this set 0, so what those variables can be there. And an example here would be y equals 3 times x minus 4 times x plus 3. So our roots would be 4 and negative 3, because 4 minus 4 is 0 and negative 3 plus 3 is 0. On the back here, you were asked to imagine a situation where a ball is thrown up in the air. This represents a quadratic function and a parabola. So let's start with a ball being thrown up in the air. Okay, and actually I don't even need an axis there. If I throw a ball up in the air, that's what it looks like. And let's say here's my x-axis. Okay, we can put a y-axis on here as well. The y-axis can move. If I change my y-axis, if let's say I start right here, then the ball is being thrown up from where? The ground. If I start my y-axis here, then the ball is being thrown after being moved up into the ground, or above the ground. So in this situation, what do the roots stand for in the real world? So our roots would be right here and right here. That would be where the ball is on the ground, or at the 0 level, because it's 0, whatever we're measuring here in height in inches or feet, we're at 0 when we have those roots. What does the vertex stand for? Well, the vertex would be our highest point, so that's going to be the highest point of the ball. Okay, so that's the max height. And that's all we really care about. As I said before, our y-intercept can shift. Okay, so if this was our y-intercept, that's where the ball is taking off from. If our y-axis is here, then the ball's not even thrown for a couple seconds or minutes or whatever we're measuring time in, and then it comes off right from the ground level. Okay, so like this might just be kicking a ball, or this might be golfing from a tee where you're just a little bit above the ground. This might be throwing off of a chair. This might be throwing off of a building. Wherever your y-axis is, that can change. Okay, and then you were asked, imagine quadratic function in standard form, explain a way or two or three ways to graph it. Okay. So if we are given this is in general form, we could factor it and get into factor form. With general form, we know C is going to be our y-intercept. Okay. So we have a y-intercept of C. Okay, we could factor it and get it into x plus r1, x plus r2, and then this is our roots are going to be negative r1 and negative r2. Okay. And then if we can't factor, we could put it into vertex form and get our vertex, or if we can factor, we can use our roots, add r1 plus r2 and divide by 2. That gives us the x of our vertex right here. Okay, and then plug in the x of the vertex, and that'll give us the y of the vertex. And then we should be able to come up with our shape. So manipulating between the three, I'm sure there were a lot of right answers here. There's not really a wrong way to graph it. There's many different avenues to take there. And then these questions here. Why would you need to complete the square? Well, we need to complete the square to go into vertex form. Sometimes it's easier to solve symbolically. So if you are given an equation, and so here, if we were wanting to solve symbolically, we would try minus 2, then we have negative 2 equals x squared plus 6x. If we wanted to complete the square there, or if we wanted to solve symbolically, we're stuck. So we need to complete the square so that we can then get to a point where this would just be x plus 3 squared. Then we can square root, and solve from there symbolically. So that's one way. If you want to just convert to vertex form, if we want to find our roots, there's lots of different ways or needs to complete the square. Why would we need to use a quadratic formula? Anytime you want to find roots or find out if there are roots, which leads to the next question. When do you have no solutions in a quadratic? Well, you can have parabolas that look like this. All of those have no solutions to the quadratic formula because they have no roots. They do not touch the x-axis. So usually what will happen there is when you have that minus b plus or minus, you'll get a negative number here, a negative number there, and since you cannot take the square root of a negative number, you know that those roots don't exist. So that's one giveaway. How do you convert from standard form to factored form? You can factor by making sure, so if we have ax squared plus bx plus c, you need two numbers that multiply to c and add to b to factor. To vertex form, you can complete the square. And how do you convert from factored form to standard form? So if we have x plus 3 and x plus 2, we're going to FOIL. We're going to do first, outside, inside, last. And that is how we do that. So if you have any questions, feel free to email me. Make sure you review anything from the study guide that you don't understand, and we will see you for the test tomorrow.